so we can eat, because I know I'm hungry too. My name's Jonathan. I've been talking about Monotouch Days. I actually started way back in the Novell days in the community, doing debugging with console write line statements because there was no debugger at that point in iOS land. So I've been working with it for a long time. I've actually been part of Xamarin now for about 2.5 years, well now Microsoft. And so I love the product. I've been working with it forever. It's something I came to organically, and now it's something that I love doing every day. So I'm on the components team right now. I live a lot in making bindings. Lori mentioned these binding projects. And one of the cool things about those I just want to add is that we have bindings to a lot of the popular libraries out there already. So you can pretty much look up any major iOS or Android library that was written in Objective-C or Android. Probably we already have bindings for it. So there's a lot out there that you can use. So anyway, we're going to talk about connected and disconnected apps. And not all of you have done apps yet, but as you do them, you'll get to notice that this is a really important thing, worrying about your connection and how you deal with your data. So first of all, we're a bunch of people that love apps, right? Does anyone have a phone that doesn't have third-party apps installed on it? No, I didn't think so. So there's about 189 million app downloads between the app stores every day. These are some statistics that we gathered from various sources. And so that's a lot of different app downloads. Now, of those app downloads, we spend about 200 minutes a day on our phones, on our devices. So that's over 3 hours. Right? I'm probably guilty of even more than that. I'm sure a lot of you are as well. And so of those 200 minutes, we spend about 127 of them in these third-party apps. Now this isn't just like texting or internet browsing, this is in apps that you're going to download from the App Store. So there's a lot of time that we're spending in these apps. Now, unfortunately, not every user downloads all of our apps, but the average user has about 36 apps installed. This comes from Google doing some analytics on the Android devices. So they've measured this is about what the average user has. I probably have about 100. Anyone have some crazy amount, like 500 apps installed? No, not too many. But of these apps, only about a quarter of them get used daily. So that's not that many apps. And we want you to be that quarter of those apps on people's phones. We want you to be successful. So there's a number of things that we have to try and do to be that quarter of those apps. And a quarter of these apps are never used. So maybe they were installed and never launched. Maybe they were launched once, but the user actually doesn't do anything with them. They're just sitting on the phone, buried away in some folder, never used. We don't want you to be in that quarter, right? That's a bad quarter to be in. So why are these apps never used? Well, it's a number of bad app experiences that usually lead to this. Your app might be slow or laggy. It might be written in Cordova, and people don't like slow and laggy apps. Or you might have a slower device that you didn't account for. So this is something that we have to be cognizant of when we're developing apps as well. Let's make a user experience really good. Crashes. If your app crashes, your user isn't going to use it. There's a statistic out there that says if your app crashes twice, your app is 20% more likely to never be launched again after that second crashed. So, don't make your app crash. It counts from the moment that the user installs the app on your device. There's also apps that are very intuitive. Anymore, I don't know if anyone's tried to look for ideas for making apps, just for fun. I do that often. Anytime I think of an idea for an app, I go to the store and there's like 5 apps that already do the idea that I was thinking of, right? So there goes my $1 million, right? So the point is, if you have an app that's not intuitive, the user can just go back to the store and find a better one that is. So you need to be the best of that category for the app you're making. And then there's apps that maybe don't work quite as they advertise on the App Store. It's pretty easy to say, hey, my app does all these things and get users to download it, but if it doesn't actually do what it says, then they're not going to use it either. And finally, this is what we're going to focus on just before lunch here, is your app needs to have its data available when users need it. So in our world, we talk about, our devices are always connected technically, right? But in reality, that's not always the case. We don't always have a good connection. We might have not have coverage at all wherever we are. So this is an actual problem that we really need to deal with a lot. Here's a nice little map. Now, this has got most of the US on it. Map that would make me terribly happy. Oh, I can't do it anymore because I'm on presenter mode. I usually like to zoom in a little bit on more of our part of the North American map. So this is a map from OpenSignal that's showing some coverage in the various places. And you can see a lot of blank spots up there in Northern Ontario. The one that I kind of like is this one up here where it's like there's like a highway and then all of a sudden, you know, you're just kind of SOL. So sorry. So, you know, coverage isn't necessarily a given everywhere. So this is something that you have to worry about. If you're driving down the highway and you open up the app that you need that data from and you hit that spot, and since you can't, you know, access the internet, all of a sudden you can't see the data that you need, that's not going to be a happy user. So the problem is amplified even more when we look at other countries, and you know, you might not be supporting African countries immediately in your app, but if you have an app that applies to the whole world, you want to sell this in as many places as you can. So if you look at Africa, like there's the trend here is that, you know, coverage is focused on areas of population, and a lot of people will even go into a town for a day just to get coverage to download some data before they go back home. So we really need to be aware of, you know, not just our own country, which is arguably pretty well covered. And the problem's even worse if we take away, you know, if we only look at 4G coverage. So not only do you have a data connection, but is it fast enough to do what you need to do? Are you optimizing your data synchronization for that story? So coverage is just, again, it's not necessarily a given. And so if we want to talk about having our app provide users with data, usually that's coming from some kind of backend. So we're going to be talking today about the different ways that we can get data synchronized locally to provide users with data when they don't have a connection. So we have a lot of options with Xamarin, and that's one of the things that I really like about Xamarin is we don't, you know, tie you down to anything. You can do whatever you want ultimately. You know, you can use Amazon, you can use IBM, you can use Oracle, and I am a Microsoft employee now, so I do have to toe the company line. However, before I became a Microsoft employee, I would have told you the same thing. The story of using a backend service provider, Azure works just insanely great with Xamarin. It did before we were acquired by Microsoft. And that wasn't exactly, you know, a mistake, but you know, it fits so well together because they provide great developer tools. They provide great APIs and SDKs for us to use. And actually, I have a podcast called Gone Mobilecast, gonemobile.io, if you want to check it out. I record this with my friend Greg Shackles, who works for a company called Olo. They do online ordering for a whole bunch of big restaurant chains, like Five Guys and different places like that. And he actually, we were talking with some Azure folks on our last podcast that we just recorded, and he said something that was really interesting to me. He told them, he said, you know, I've worked with EC2, Amazon's EC2 a lot. We've worked with a few other cloud providers, and we keep coming back to Azure just because the developer experience they provide is so amazing. So, you know, as much as I'm supposed to pitch this to you to use it, I don't feel bad doing so because it actually is the best solution out there to use, especially with Xamarin tools. So we're going to talk about Azure today, and I already kind of talked a little bit about it, but it is really powerful. You can use it for many different things. You can create virtual machines. You'll see when we go into the portal, there's a whole bunch of different services that you can choose from and make. It's really, really good. It's flexible too. You can, you know, it doesn't tie you down to SQL Server. If you want to use that, great. It's easy to use. But if you wanted to use MySQL or you wanted to use MongoDB or something like that, we don't tie you down to just using one thing. And same goes for app services. If you don't like C#, well, you can write your backend in Node.js. That's fine, right? In fact, I think Node.js is now the default app service backend when you create a new app service, and we'll see that in a little bit. And of course, you know, C#, we're all .NET developers here, I think we established already, so C# everywhere is awesome. The SDKs work on iOS and Android for Xamarin, as of course Windows too. And they're all open source as well. Microsoft writes them out in the open. You can send pull requests. And then talking about this backend, you know, this app service part of it that I said you can write in Node.js. Well, you can also implement that backend in your ASP.NET website, your ASP.NET Core website. So we give you a bunch of different options. And the thing I like is that as a C# developer, I can use C# in every spot, you know, on Azure, on the client, everywhere. So, you know, reiterating that, you saw a slide earlier of, you know, sharing your C# code between platforms and how that looks. And, you know, now just want to be very clear that you can run your C# in Azure, but then that also opens up the possibility of sharing your code between your client and your server architecture, right? So if you have some models and stuff like that, you can share the code. All right, so how does this actually work? Well, Azure has a whole bunch of different services. We're talking about the mobile app service offering that they have today. And this is basically, you take your client SDK and you point it at a RESTful endpoint, which is this app service that is running on Azure. And this RESTful endpoint contains functionality around data connections. Like I said, you can hook it up to Mongo, you can hook it up to basically whatever you want. The sky's the limit, you can customize it. It also allows you to easily add user authentication to your app from all of these providers. So has anyone dealt with OAuth providers before? Yeah, how is that for you? So they help us do this. All we have to do basically is go in and set our client ID and client secrets for the various services in the configuration panel, and boom, we've got authentication support. And actually their mobile client SDK, we're not going to look at that part today, that part of the SDK, but they make it really trivial to do the UI for actually logging into these services as well. So that's pretty cool too. It's really simple to use. And then push notifications. Anyone worked with those before? Oh no. And so these are very near and dear to my heart because I have an open source project called PushSharp, which I don't maintain as well as I should anymore. But it was, the idea of it was dealing with all of these different platform providers, because for Apple you have to talk their format to send push notifications, and Google has their own formats, or several of them, and so does Windows. So they help us with this too, where we can just say, hey, send a push notification, and they'll take care of the hard work of doing that. And if you catch me on a bad day, I can tell you about how much work Apple makes it to actually send push notifications. So it's not that easy. The coolest thing of this is this offline sync, and this is what we're going to be looking at primarily for. So they've given us this API for doing offline sync. We can hook that up to various data connections. We're going to look at SQL Server today as our data connection. And then from your client, you use the same API for your offline sync. And this is helping you really, really easily get data to and from the servers. And it helps you deal with conflict resolution. They have a basic sync handler that deals with this for you, so you don't really have to do anything. It'll just, it follows some of the most observed rules of conflict resolution for this kind of setup. But you can also customize your own and do whatever you want with that. So it's really powerful to have this really simple API to use. And then I mentioned backend code. So within this functionality, you can also run basically whatever you want on the backend. You can do it in a variety of languages. You can push it from GitHub, from Bitbucket, from TFS. Basically, again, it's totally customizable, which is the big, powerful beast that it is. So to use a mobile service, it's really simple. We create a new mobile service client. And this is using the C# SDK that I just talked about. We pointed at that RESTful endpoint, so this is what we'll get. Yours won't be, it won't be my app, it'll be whatever you name your RESTful endpoint app. And you point it there. Once you have an instance of it, if we want to do this offline sync, we have to get an instance of our sync table. So there's this interface that we can pass in the type that we want to synchronize. So this store object, let's say we had a app that showed a list of all of our store's locations. So maybe you have a store object with the name of the store, the location of it, etc. That's going to be an object that we synchronize to and from the cloud. And so when we initialize that, we have to tell, first of all, we have to create this mobile service SQLite store. This is a default store implementation for the local client. This is provided for us. We don't have to build this, but if we wanted to, we could make our own store. We could just implement the interface that the mobile service SQLite store implements, and we could do like Realm.io if we wanted to. So under the hood, of course, this uses SQLite. It's good enough for most options I've found so far, but I do think I've been on the train of thought of making this Realm.io. Has anyone heard of Realm for mobile? Yeah, a couple people. So I think I'm going to make one of those. So when I do, I'll put it up on Medium. So you create your instance of the store, you tell it the file name you want it to be stored in, and then you define your table, this same object here. Once we've done that, and this code is a little bit more verbose than we actually need it to be, you used to actually have to create an instance of the default sync handler. This is what handles the conflict resolution for you. It's like this default implementation that they did. And then pass it into this initialize async method. You don't actually have to do that anymore. Explicitly, they'll use the default handler if you don't pass anything in. But that gives you an opportunity to, again, implement an interface to make your own synchronization handler if you want. So once we've set up our synchronization context with our handler and our we can call that on our mobile service to get an instance of that sync table since it's all been initialized. And once we have this table object finally, this is what we actually use to start inserting data, pulling data, pushing data, and you'll see that in just a second here. So, not too onerous to set up, a few lines of code. And so here's an example of actually using that table. So if we want to get all of the stores, we would pull all of the stores from the cloud. So this pull async is going to actually fetch all of the new data that we don't have locally synced for us in the cloud. Now, there's a couple things going on here. One is this identifier. This identifier is what the local SQLite store is going to use to store what is the most recent point of data that it has locally. So that when it's going up to the server, it's only fetching the differences, it's only fetching the changes. So this identifier needs to be unique for any unique query that you're going to do. And what I mean by that is any unique query you create here that you're going to use in this pull async statement. So generally, you'll probably just use the one. There's maybe more sophisticated cases that you might want to have multiple different queries that you're syncing locally. In this case, we're just going to call it all stores. Create an empty query, so this query is going to return all of the data. You might want to narrow this down to a particular user ID or something like that. And then finally, we can just call to enumerable async on there on that table to give us all of the actual records back, and that's going to give us this enumerable of type store. Now, if we want to add a record to the database, we use this table instance again. I don't know, it's kind of low on there, but basically we call an insert async. That's going to insert that store record to our local data store. Then think of this kind of like source control. We want to pull all of the changes down after we've committed our local change, right? We want to pull all of those changes down again. We want to synchronize that down again. And then after we've done that, we can go ahead and push all of our local store back up to the cloud. And so that's just calling this push async. And that's it. That's all we have to do to synchronize our data from the cloud back and forth. So it's pretty easy. And I want to actually go through a little demo of what this looks like. How many people have used Azure before? Okay, good. So quite a few people. How many people have used the new that portal.azure? I know I was really resistant to going to that from the old thing. So a few of you, that's great. All right, so let's first of all look at portal.azure.com. Oh, how responsive is this? It's not bad. Not bad. All right, so if you don't have an account, you can sign up at azure.com and get an account, free account. I was looking last night, they actually give you, I think, $200 credit when you sign up for a new account right now, which is not terrible. So I have a little bit of money left on my account, luckily. So this is the Azure Portal dashboard, if you aren't familiar with it. Now what you're going to want to do, and you're going to do some of this in the lab later, is create a new service. So there's a whole bunch of different options that come up here, and you don't even see the specific ones, you see them categorized for now. So if I search for mobile, let's just do that and see what comes up. I've got a whole bunch of options here. I have a mobile app, which is what we're going to be working with. Now this mobile app is like an empty shell, so like it doesn't create any sync tables or anything for you. This is what you want to use if you're kind of familiar with it, what you're doing. But we're going to use today this mobile apps quick start. How's that coming up? Let's zoom in a little bit here. So we're going to use this mobile apps quick start, and this is going to pre-configure some things for us. Now, I was up too late last night figuring out that people who program things for Azure are just developers, oddly enough. They're not some infallible type of person. And there's actually a bug right now on new instances of this quick start that you create. So by default, they create a SQLite database on the server side for you as well. And that's not working very well. So we're going to avoid using the SQLite database, and we're going to go straight to a SQL Server database to store all of the actual mobile data. So there's a bug out for that. Hopefully they fix it soon. You wouldn't really want to use SQLite in production anyway. It's more of something you just use for testing. So what we would do is we'd go ahead and say, let me zoom back out here. Yep, I want to create that. And we'd enter a name for it. Xamarin Dev Days 3. You pick your subscription you want to associate it with. Add an existing resource group or create a new one. So a resource group is basically just a container to put multiple services under, so it's easy to manage them. So if you have a particular app, you might want to make a resource group for that app so that you can put everything in the same bucket. So we would call it maybe Xamarin Dev Days 3 again. Then we pick our subscription, and you notice that I have a Canada East instance now, because now Microsoft has data centers in Canada, which in a former life at a school board was actually a really big deal for us, so I'm glad to see they finally did it. So you can choose your subscription plan, you can create a new one. There's a bunch of different pricing tiers. Now, unfortunately, they're kind of sly about it. By default, they show you their recommended pricing tiers. If you view all, you can see a whole bunch more. So we could spend a little bit of money on that if we wanted to. I have the standard one selected, which isn't too bad even, 50 bucks a month to run your app. There is a free version. This isn't going to get you much past doing some testing and development, but it'll get you with that at least. So you can choose the free version. There's a shared version, which is a little bit, maybe more testing. I think they still don't really recommend it for production use. And then there's some basic plans. So you can pick one of those plans to suit your needs. If you compare it to like a cheap hosting plan, it might seem a little bit costly, but you get a lot of functionality for doing it. So I think the pricing is actually pretty good for what you get now. So we're just gonna back out of this. I'm not gonna actually make this new instance right now because I already have one created and they take a few minutes to spin up. But back to this first page here, basically you would want to pin to dashboard and then create an instance. And once you created it, just close everything up here. Once you created it, you'd see it on your dashboard here. So like this is my Xamarin Dev Days 2 I created. That actually is working. It's hooked up to SQLite backend. So that's going to be what we're looking at. So if we go into this, we could go to this Connect Client Apps, and this is going to give us some tutorials and SDKs and documentation about how we would actually connect up our client app. It's not loading very quickly, unfortunately, but we would see, here we go. You can see there's, Xamarin Forms is one of the templates here that you can use, and they kind of guide you through it, so they make it really easy to get up and running. Made a whole set of documentation. Here's the actual mobile app instance that we spun up on Azure, and there's a whole whack of settings in here. I mean, we can see the requests and the errors. We can see, a whole bunch of settings, everything from what PHP version and debugging information we want to use if we're doing that for some strange reason. All sorts of settings that we're not going to go into, but you can play with those. Then we've got authentication. I mentioned we can do social authentication. So if we go in here and turn this on, you can see here for, let's say I want to enable Facebook authentication. If I go to Facebook's developer site, create an application, I just paste in my values here, set it, save those values, and boom, I'm configured for doing Facebook OAuth authentication. Azure helps us with this. We've got easy APIs, which are basically, you can create your own RESTful endpoints and have your own code to do whatever you want. That's kind of handy for some things. We could go ahead and edit our site code right from here. So by default, it's a Node.js backend that they give us. We could switch that if we wanted to. But I can go right in, and they've got VS Code online, and I can edit all the JS code. I can install NPM modules. I can do whatever I want right from in here. So that's kind of cool too. And you can see that they're tables. You can edit the code for the actual tables. We're just using their default implementation, which we'll get to in a second. Like I said, there's a console here that I could, if it actually opens up. Did last night, I promise. Anyway, you can do all that from there. I don't really like looking at JavaScript code, so I'm not gonna. So the last thing that we want to look at, this is our primary focus, is these easy tables here. Oh, yeah, fine. So if I go into the easy tables, we already have one created for us since we used this quick start setup. It's called to-do item. So we can go into that table. And you can see here, there's no data in it right now, but if we looked at the schema of it, we would see all of these different fields. We've got an ID, a version, created, updated, added, deleted, text, and complete. Now just keep in mind the text field, the name of it, and the complete field, because that's going to matter in a second here as we dig into the code. So this is where we actually want to be putting our data. And we can view it, once we have data in there, we can actually view it right from Azure here. We can edit the data, we can delete the data, so that's kind of handy. But now I'm going to jump into the code to this to-do app that we have. So I'm just going to zoom this in. So we've got this solution set up. Now we already have this portable class library project for us, and then we've got, and we're not even going to open these other libraries up. We've got Droid, iOS, and Windows Universal. Because we're using Xamarin Forms here, we don't really have to do anything specific to those platforms. We're going to do all of our code in this portable class library. So in this PCL, we've got a constants file. We're going to open that up. I'm just going to go through the file so I don't have to zoom in and out and make everyone dizzy. So we've got a constants file, we've got a to-do item model file, and then we've got this to-do item manager, which is how we're going to interact with Azure to actually shuttle data back and forth. We've got our page, our to-do list page, which is just a bunch of XAML to show our to-do list items and the buttons and everything. We don't really have to look at that too much. And then we've got our application class, which is incredibly simple as well. So let's look at this constants file first of all. So remember, we need to set up our own RESTful endpoint here. Well, I have one called Xamarin Dev Days 2. That's actually doing what I want it to be doing right now. And that's all we have to do once we to use it with our mobile service client. So we'll create a new connection of that in another spot. But let's just take a look at this to-do item model. So this is what's getting synced up to that easy table we just looked at. So we've got an ID field, a name field, and you can see here we're decorating them with some JSON property attributes. So this is using Newtonsoft to do some of the JavaScript or JSON serialization. And we just have to make sure those property names match with the columns that we had back on the Azure side of things. So, in this case, the column name is actually text, even though we're calling it name here. We've got a complete property to know if the item was done or not, and then we've got this version property. And you'll see here that there's this version attribute, so that's kind of important. That needs to be there for the local sync store to be able to know that that's the version column to handle the synchronization states on. So that needs to be there, but that's kind of it. Otherwise, you can have your own properties, whatever you want on there. So that's our model, and then we've got our page here. I'm not going to go into the XAML code for it. It's kind of not really relevant in this case. But we've got a few event handlers set up. You'd probably want to do proper commands and a view model and everything, but this sample is just doing it really simply. So we've got this command for adding an item, and basically the story of this page is anytime we have like an operation like adding an item, we're actually just calling out to this manager. This manager save state async, or save task async. And so the manager is what we're really looking at to see how it interacts with Azure. This is kind of all just plumbing code. So we're going to go jump into the manager class. And this is where it gets kind of interesting. So you can see here we've got our mobile service client set up. Can you guys read that back there? I'm not going to zoom in over and over, but you can. Okay. I'll take that as a yes since no one said no. So we've got our mobile service client using that constant URL that we defined. We give it a database name. I'm just going to change this for testing purposes to make sure I don't do anything with previous tests I've done. So that's the actual database that's going to store it in locally. We're defining our table. We're initializing our synchronization context. Remember I said we don't have to pass in a default sync handler. It'll use the default one if we don't, so that's what it's doing in the code. And then we're getting our to-do item, table, or to-do table, which is our actual sync table. And so if we look at an operation for, let's look at the get to-do items async. So we have this method here, which we're going to say if we pass in a true as this parameter here, we're going to actually tell it to synchronize. So that's what we're checking here, and we'll look at this method in a second. But if we're not synchronizing, or after we're done synchronizing, to query from that table, we'll query from that local store. All we do is use that to-do table, and we can use link on it. So we can say, give me all of the to-do items where they're not marked as done, because we only want to show the items that aren't marked finished, right? And so we're just going to return an observable collection of those so that it all gets data bound to our list. And then we've got this save task async, which is what we were calling from that page. So if it has an ID, we're going to update the existing ID, otherwise we'll insert it. And then I mentioned jumping down to this sync async method. Let's not have breakpoints everywhere. So what we're doing here is, first of all, we're going to push our changes up. We're going to pull all of the changes that we found down using the same identifier and just an empty query so we get all the items. And then we're doing a little bit of error handling here, so you can do some simple conflict resolution here as well. This is just giving you an example of this. So we're going to catch this particular exception, and if it happens, then we've got some conflicts, some errors. And if we jump down here to this section of sync errors, we can actually check through each of these different errors. We can see what kind of sync error it is. So if it's an update error, this is probably something where like I pulled down some data, somebody else pulled down the same data, they made changes, pushed their changes back up, And then I tried to push my changes of the original copy of that data back up, and SQL and the Azure is saying, hey, wait a second, there's newer changes that you haven't accounted for. And so if that's the case, we can tell it to simply revert back to the server's copy that other person checked in. And then if we have some other kind of error, then we just want to kind of say, hey, don't use my changes, and we don't want to screw anything up. We can just discard all of those item changes. So there is some basic stuff you can do here. Like I said, you can also implement your own handler with this iMobile Service Sync Handler interface, and then you have a lot more control over that, how to handle conflicts. So that's kind of cool too. My internet's gonna be down here in a second, so let me agree to the library internet. Okay. So that's all the code that there is for this app. And now you haven't seen what it looks like, and we're gonna run it now. So let's start by running it on, let's do iOS, because I want to show you that whole remote simulator connection to the Mac here. So I have my Mac running. This is my build agent. My build agent is not connected. It's probably going to pop up and ask me to connect if it's not. Okay, so this is what you'll see. You'll get a little dialog. I already have it configured. So I'm going to just tell it to connect. Should take a second here. And once I'm connected, then all of a sudden you'll start to see all of my simulator images and stuff that are from my Mac are going to pop up on my Windows machine here, and I'll be able to choose which one I want to run my iOS app on. Don't make a liar out of me, Mac. Connect. You know what? Let's try just adding this quickly. It's always sketchy when you're trying to do things over public Wi-Fi. Oh, I'm not on the same access point. That'll do. One second. Alright, now I think I should be able to tell it to connect. I cheat and I bring my own little router with me wherever I go and connect all my devices up to it. So, anyone know any good jokes? So this app, like I said, it's configured for Android, it's configured for iOS. You know what? I don't know why that's not working right now. It's working perfectly this morning. So we're going to skip that for now and just we're going to run the Android app first of all. So you can see here I switched to Android, and as soon as I did that, let's just scroll up here, I get a list of all of these different emulators here, right? So I can choose from the different API levels and everything for emulators I have installed. I'm using the Xamarin, not the Xamarin emulator that Lori was using. I'm actually using the Microsoft one, which is really, really well done. So here's the emulator, and we're just going to wait for it to deploy to this phone, and then the app should start up. So you can actually go in and choose, images for different API levels. It's really fast. It uses virtualization, so it's a great one to use. You can even download that one. I really like it now. All right, app's launching. So we've got a really simple interface. There's no data there yet, right? We didn't add anything. So we can simply add an item. Let's say I want to eat lunch. So we hit add. Now, once we hit add, it shows up here, but this is only to our local store. If I come back in here and refresh my table, it hasn't synchronized up here yet because we haven't actually pushed those changes back up. So this is, the nice thing about using this is we're kind of in offline mode in the sense here where if we close the app and come back into it, that data will still be there because it's in the local data store. So what I need to do is hit the sync button. That's going to send that data up to the cloud, and sometimes this refreshes on its own and it's even more like, wow, I did it. But here's the data, I hit refresh, now it's actually up here in the cloud. And now the cool thing is I'm just going to stop this application. And I'm going to run it in UWP, and what I'm going to do, instead of debugging, I'm going to start without debugging just so that I can try and launch the iOS one right after again while we're looking at this. So the UWP app looks pretty similar. This is Xamarin Forms. We didn't do any specific UI code for each one. You can see here there's nothing in the database locally because we haven't synchronized the changes down yet. So if I hit synchronize, boom, there's our eat lunch. That came down pretty easily for us. So let's launch this app on its own. And let's add a hello from UWP here. So again, because I haven't synchronized it yet, even if I synchronize on Android, it's not going to be there yet. But once I synchronize from UWP and then I synchronize Android again, hello from UWP. So even marking tasks is done. So I have to press and hold this one to mark it as done. If I mark this as complete, and then I synchronize my changes back up, this one should disappear. And so the only task we have left is to eat lunch right now. So I'm going to try to power through the rest of the couple slides we have so that I don't have to smell this pizza. While we're eating lunch, I'm going to see if I can get the iOS thing working just so you guys can see it, because it is pretty cool. It's just a challenge always on public Wi-Fi. All right, so we worked with our backend. We added a backend, or I had already done that. We talked about how we can share all of that code between the backends. Right now we're running Node.js, but I would love to switch it over to C# and use that everywhere instead. I showed you a little bit about the authentication. So again, we're not going to go into detail about that, but like I said, you can use all of those social providers pretty easily. Like I said earlier, the UI code is really simple with the Azure Mobile Services Client SDK. And then push notifications, I complained about that already, so I don't think you need to hear that again, but they make it super easy. And this is actually, so I had this push library. It did quite well. It was actually at one point in the top 10 C# starred libraries on GitHub. But then I kind of stopped doing it because I was like, well, this is so easy. And it's like, I think it's $1 for 1 million notifications to use Azure to send. It's like, you're not going to roll your own server to do much better than that. So I just started telling people to use Azure. But then people didn't seem to take that so well. So anyway, use Azure. It's way easier. You'll save yourself so many headaches. So we did data synchronization of like the structured table data, but what we're not going to show you, and what you can also do is sync files just like that, just as easily. So if you have pictures on devices you want to sync together, you can use Azure for that. And then, this Mike James, my buddy Mike James in the UK, he's one of our other great evangelists. He decided that 4 lines of code was simply the right amount of code that you needed to use Azure App Services. So when I showed you some of the original stuff, it was like maybe 10 or 12 lines of code. Like that's pretty tough, right? We're getting paid all right to be writing 12 lines of code. But no, now you can do it with 4 lines of code with this app service helper. So he made this NuGet package. It's built on top of the Azure Mobile SDK. It just does stuff a little bit easier for you. So we're going to use that this afternoon because we're developers, we're lazy. So basically, here's the 4 lines of code you need. You create your easy mobile service client because the other one wasn't easy enough. And then you initialize it, you register your tables, and then you finalize schema, and it'll take care of actually doing all like the SQLite mobile store and initializing the sync context and doing all that for you. So it's cool. You can go grab it on GitHub. And yeah, we'll use it again after lunch. And finally, I think we get to eat. So thank you for listening to my rambling, and you may want to say something about lunch.
Awesome. Thanks so much, Jonathan.
And that's the whole point. Like it's trying to do what changes doing this.
The demos that you've seen, as well as the hands-on labs. So definitely do that over the course of lunch. We're going to take an hour break. So from 12 to 1, it's just we're going to eat, we're going to get our machines going and set up, and just network and talk to other people. If you're having issues with your environment, definitely grab Mark, grab Jonathan, or myself. We'll come over and help you get that sorted out. And pizza's at the back. If you are a vegetarian, there is a vegetarian option. There's 3 stacks of pizzas right there. The vegetarian option is the 3rd stack. So have at it. Have a good lunch, guys. Thanks. There's a README file that gives you instructions step by step on what to do. And you can start off in the starter project. Open that up. Make sure you can build it. If you're having trouble building and running, and you're running into kind of obstacles with that, let us know. But don't let that hold you up. Try and get through some of the steps of understanding like the architecture of the application, the code, where the code goes, where the layouts are, how to formulate the project, and kind of get your app, architected. And then we'll help you with some build issues where we can. Okay, so definitely get started. Raise your hand if you are having issues. I'm gonna come over and see you, and then we'll, between Mark, myself, and John, we will help you guys out. So, yep, get to it. By updating the NuGet packages, and you know that your Android SDK is up to date. I would recommend just creating a new project. Pick blank Xamarin Forms portable template in the cross-platform section. Build that, and if that builds successfully, then just start adding in the project files from that starter project into that new project shell. There seems to be some kind of references that seem to be mucked up.
Yeah, I think it's what happens is when you install some of the Android support library components or NuGet packages, because of the way Google's licensed them, we can't actually redistribute those. So at build time, it's actually going out and fetching that from Google for you. And it's like a 260 meg file. And so given network conditions, I've seen it once already where it's been a corrupt download. So if, the other thing that we can do is I can put up the path where you can delete some files from and try rebuilding and see if it takes. Yeah, that one's a tricky one to do in this setting.
Yeah.
That's your work.